Hello, everyone, and welcome to this very interesting web series which is on machine learning fundamentals. We are going to discuss a very interesting machine learning algorithm today that is random forest. This is episode 12 of this series, and in episode 11, we had discussed, in fact, a lot of different aspects. First of all, decision tree, and then, in fact, various aspects that are related to machine learning. We had discussed the problems of underfitting and overfitting. What is underfit, what is overfit, and what is good fit. So, with the examples and implementation, we had taken the examples in Python. And after that, some of the measuring concepts, in fact, for measuring the performance of a particular machine learning algorithm, we had taken some of the very critical aspects like confusion matrix. We had taken precision, recall, F1 score, and support. And these, in fact, we had done the interpretation of an output of a particular particular problem with decision trees, with the decision tree classifier. So those are very important aspects in fact going forward in this series. And today we are going to take a very interesting machine learning algorithm which finds its implementation in diverse applications, and it is in fact known in some of the applications, and provides comparatively it provides much better results when we compare it with some other machine learning algorithms. So it outperforms them in certain categories. A very intuitive, I would say, innovative kind of machine learning algorithm, sorry, called as random forest. So without any further ado, let me just go directly and showcase you this random forest classifier. We'll be taking it end to end from theory to implementation. However, it might well happen that for this series or episode 12, you might be having episode 12A and B, which normally happens in those videos which go little lengthy. So that might be happening here as well. Let me just go to there. I will be just taking this. What is the motivation behind this random forest using random forest classifier? So there were certain issues mainly there in decision trees. So what were those issues? For example, overfitting due to high sensitivity to the data. So that was a problem which we in fact addressed as well. In fact, we were having one more issue, which is small data changes, and then it is in fact taking the tree structure entirely. So definitely we'll be taking this, small data changes which were there, very different tree structure. So that is second issue which was there as already in fact discussed. So two, certain major problems. One is overfitting, and one more is very different tree structures for the small data changes. So what is the solution for that? Solution is that we are putting an ensemble. So what is this ensemble first of all? Ensemble will not be utilizing here only this concept of ensemble. Ensemble is when you are combining, you are putting a combination of multiple things. So that combination is giving you result output at the end. So what does that ensemble mean? I'll just clarify this. Ensemble is a combination of multiple outputs. For example, in case of a decision tree, we were getting an output from a decision tree which was working on the logic, which is very well explained in the previous episode, 2 3 episodes, in fact 2 episodes which are there, that how decision tree is working, and the concept which is there explained in mathematical manner, mathematical equations, for example entropy, Gini impurity, information gain. All of those things have been explained in a very detailed manner. So based on that, a particular decision tree is outputting a result. Now, when we are saying ensemble, we will not be taking result of a single decision tree. We will take output of multiple decision trees and on the basis of a logic, certain logic, for example, majority vote, will be finalizing which output is the final output, what is the final prediction of the machine learning model. This is exactly what happens in random forest. Now, this ensemble method is not only used here, we might be using in future ensemble for multiple machine learning models itself. So that is something else. So we might see that, ensemble of two machine learning models in a particular use case, in a particular scenario, is enhancing our prediction capabilities. It is enhancing the precision. It is enhancing the it is enhancing the various other metrics which are there for the performance of machine learning algorithm. So if it is enhancing those metrics, we'll be using ensemble of two or multiple machine learning models. So ensemble is actually a concept where we are combining. So in random forest, what is being combined? It is multiple decision trees, not a random forest is a combination of multiple decision trees, not a single decision tree. So we have seen the single decision tree before, but it is a combination of multiple decision trees. Instead of one unstable tree, we use many trees combined for better stability and performance. We are using multiple trees, not a single tree. So definitely it is going to give us better performance and stability compared to a single decision tree which we used to have before in the decision tree classifier. So this is, as I was pointing out, this is an innovative way, intuitive. So there's definitely an intuition behind random forest. And what is that? Multiple decision trees are trained on different data sets. So it's not the same data set. It will be the same problem, but the data set will be varying. It will be differentiated, and it will be shown as well how we can have different data sets for different decision trees. Each tree independently vote for a prediction. So independently they are putting their prediction out, and then the final output is determined by the majority vote. So we will just check how many decision trees are outputting the same result, same prediction. So the majority of the decision trees which are giving the same result, that result will be taken as a final result, final prediction. This is the concept behind decision trees. It's very simple. If somebody understands decision trees, the logic is same, but it will be multiple decision trees which will be there, and we will be putting it, we will be designating, we'll be putting it that how many trees we are going to take in a particular algorithm, particular case, and that will be shown to you when we will be doing the lab for this, the practical one example. In fact, I'm going to take one example here itself. So this ensemble approach produces robust, stable predictions compared to relying on a single tree. So instead of relying on a single output from a single decision tree, what we are doing is we will be relying on multiple decision trees, and by the majority vote we will decide then what is going to be the final output. This will be definitely having a better stable prediction compared to the one which we are getting with the decision tree classifier. It will be, it will not be relying on a single tree. It will be dependent on multiple trees. And then definitely for the random forest, we are having some core concepts, out of which some of them I'd like to just take up in the initial part of this series 12. So one is bagging, bootstrap, aggregation. What is this? So rather than, because we know that decision tree will be working on a particular sample data which is given, that we have seen, then there will be a training data, there will be a test data that is for all. We have taken that in quite a detail as well in previous episodes. When we are giving this data, the original data, for example, is A, B, C, D, E. Now the sample data which will be given for the tree, each tree, it will be different, because if you are giving the same tree, probability is there that it will not be giving much of the diversity as far as the results are concerned. So we want to give a diverse data set to these trees, so that we can have a diverse output as well generated, so that we are getting the best predictions possible. So random sampling with replacement from the original data creates unique training data set. So it's creating a unique training set for each tree. So the example is given. Each tree sees a different perspective, data perspective, and then definitely it will be having a direct influence on the results. The ensemble will be creating a diversity. It will be creating a diversity. So that diversity actually we want, and with that we'll be able to enhance the parameters, performance parameters of a machine learning algorithm. So in this case, random forest, definitely we will be able to enhance the performance when we are having a diverse data set given to each of these decision trees. And then second thing, which is again very important, that is feature randomness. So we know exactly how a decision tree operates. At each ciplet, it will be taking a different criteria, depending upon a different feature on the basis of which the next ciplet is going to happen. And then that feature which is there, if it is same in all the decision trees, it is not going to create a diversity. What we are trying to do here is we are trying to take different features, so random features for different trees which are there. At each ciplet in a decision tree, random forest randomly selects a subset of features. Instead of having instead of considering all available features, it will be taking a subset of features for each of these decision trees. This ensures that trees differ from one another. Definitely they'll be differing from one another. One tree will be having taking a different feature set, another will be taking a different feature. So they are going to, that is also going to create a variation there. So this ensures trees differ from one another, reducing correlation between them. So that will be reducing the correlation. The result is increased diversity. So definitely our motive behind this is that we want to increase the diversity. We want to include more and more things so that our results are enhanced, and robustness across. So we'll be having diversity and robustness across entire ensemble which that we have created. So this is the reason. And the final prediction mechanism, I have already, in fact, already expressed it, that the final prediction will be happening based on the majority vote. So for classification tasks, random forest uses majority vote across all trees. So each tree in the forest independently classifies the input. Then the final prediction is determined by the class that receives the most cases. So this is for the classification. Whichever class is there, majority class will be output. Will be taken into consideration, and that we are getting with one function called as mode, which is in fact here. So mathematical perspective which is there for this is, for example, we are having we can just represent these individual trees, decision trees, uh, uh, the predictions of each of these trees with hx, for example h1x, h2x. So for example, decision tree 1 is giving h1x as output, decision tree 2 is giving h2x, so on up to decision tree n. So for example, in our case, I'll take an example of n is equal to 10. That means we are telling that there are 10 decision trees. So the combination of these, then random forest will be equivalent to what? So random forest will be equivalent to mode of h1x, h2x, so on up to h10x in case of 10. So it will be h10x, and then that is going to be, mode is going to output the most frequently occurring class which is there. So most frequently class which is present in the series, most frequently occurring class among all the trees, all trees predictions, that will be the final prediction done by the random forest. So this is the mathematical perspective. It's very simple. I think we have taken much more complicated mathematical equations earlier in case of decision trees as well, when we were explaining in fact entropy, and we were explaining this Gini impurity information gain. We have taken much more complicated mathematical equations than this one. I think this should be quite clear. So conceptual example which can be given on the similar example that we had been taking. if you just see all the way on different machine learning algorithms. I think on this conceptual model, I might stop, and then I will showcase you. In fact, in the next, this will be episode, this is episode A. I don't want to have this episode too long, so that one will be just losing the interest then. So I am just keeping each of the episodes. It might be episode A and B, but I've tried to keep it to 25, 20 to 25 minutes, max 30 minutes, not more than that. So this data set, if you just see here, pass fail prediction, we are having student hours and attendance, same example, and result will be classification, pass or fail. Single decision tree outfits on small data. A random forest with three trees votes tree 1, tree pass, tree 2 is passed, tree 3 is pass, tree 2 is pass, and tree 3 is failed. Sorry. So tree 1 is giving an output of pass, tree 2 is giving an output of pass, and tree 3 is giving output of fail. So what is going to be the final decision? Final decision is going to be pass, because it will be the mode function which will be getting the most frequently occurring class, which is pass. Definitely in this case, out of 3, 2 times pass is occurring, so definitely it will be taking a final decision of pass. So final prediction by majority vote will be pass. 2 out of 3 trees agree with that, so it's going to be pass. If we just see the next one, the implementation which is there. So we are coming to implementation here, but in fact, I'm having a full-fledged program which will be giving you a complete, the basics of, I'm trying to take in each of the machine learning models, as I have already said in the previous episodes as well. I try to take very simple examples so that you understand the concept first of all, because what can happen is, we can, at the end of, I'm having a plan that when we'll be finishing with the fundamentals of whatever we had to take in the fundamentals of this machine learning, at the end I'll be showing you implementation of these different algorithms, whether we are talking about supervised learning or unsupervised learning, or for that case maybe certain examples might be there in reinforcement learning as well. Although much of the things, I won't say that extensive things in reinforcement learning will be covered in this fundamentals of machine learning. Actually, what with this series is intended for the basic concepts, for those who want to learn machine learning, and with very simple language, they will be, with simple examples, they'll be able to understand the basic fundamental concepts. Then it is going at the end towards implementation in different areas. For example, certain examples for supervised learning or unsupervised learning. Some of them may be for reinforcement learning as well, but certain advanced concepts at the end. And then there are separate series available on the same channel. You can just view separate series will be available for the machine learning, for example in healthcare sector, machine learning for fraud detection, machine learning for anomaly detection, machine learning for phishing detection. So such kind of things, which are the use cases in cybersecurity, use cases in finance, use cases in medical diagnosis, and such kind of series will be separately there, where it will be all advanced. So where these basic fundamental concepts will not be discussed at all. We'll be starting with the deployment of different algorithms, and then we'll be comparing different algorithms which is performing well on a particular data set. There might be a data set which will be taken from various databases which are freely available. So that is something which is going to happen. But Python implementation, create a data set, import pandas as PD. So this is a general thing which is here. And then from Skylearn, we are just importing random forest classifier, and data we are giving study hours and attendance, and then results we are putting it 0 and 1. 0 is fail, 1 is pass. And then we are saying that df is equal to pd dot data frame data, and then initializing as we are doing it with normally how we initialize the machine learning model, and then we are putting it. We are saying n estimators equal to 10. That means number of trees which are there in this. So n estimators, you should remember this. It is number of trees. And then I can in fact, from here, without going to this evaluation matrix, in fact, I would like to, first of all, because these things I'll be discussing probably in next episode, I would like to just show you one thing, which is the this program, which I have just kept for that. So you can just see this, the program which is written here. You can just see, import pandas as PD. So this import is already there. We have just taken random forest classifier from here, and then we are putting, this we have done in the previous program as well, confusion matrix and accuracy score, so that we will be able to plot a graph or give an output at the end. This is the initialization of the data. You can just see this, the results which are there, 0 and 1, 1 for pass, 0 for fail. And then we are initializing. This is not for the first time we are doing it. We have done it in similar programs. The model only is different. So here it is random forest classifier, where we are putting the n estimators as 10. So that means 10 number of trees which are there. So it is mentioning here as well number of trees. And random forest random state is equal to 42. That is something we have discussed a number of times, and why we are putting this value as random 42. Model.fit xy, so we are just predicting it here, new data. So then we are predicting it on a new data which is 6 and 72. So 6 and 72 is the value, and then we are saying that we want you to do the predictions, probability and prediction. So both of them are here, and then we are saying if prediction 0 is equal to 1, print prediction is pass. If it is equal to 0, prediction it will be fail. So it will be predicting us whether the student is here with these with these parameters is passing or failing. And then we are just putting this prediction, accuracy, score, confusion matrix, and we are printing it all, and classification report, all of that we are printing. And then at the end we are putting this, we have imported this matplotlib as well, and we are putting this matplotlib bar to show which feature, because there are two features in this. One is the student's marks, and one more is the attendance, which is a significant out of the two. Definitely, when we see the significant one would have been the student's marks, as far as the fail and pass categories concerned. So let us go directly without any further delay, and let me just run this program. So I will say run without debugging. So this is running, and I'll show you the output of the program. What is going to be the output? First of all, it is going to be the confusion matrix. No, it will be the prediction. First of all, the prediction is pass, and then it is giving the probability. So probability of fail 0.3, that means 30%, and the probability of pass was 70% in the case which we have given it for the prediction. So it is giving the probability for that. Accuracy, it's showing that it's 100%. So a confusion matrix, in fact, is in fact supporting that. It's saying that for students who were passing, they were predicted as pass by the model, and 0 students who were in fact 0 students have been predicted as fail, who were passing. So that means it is 100% here. And then it is saying 0 students who were failing, they were predicted as pass. So model has not predicted anybody as wrongly pass, incorrectly pass. Okay. So and 5 students who were failing were predicted actually by the model as fail. So if you see in this case, we are having 100% accuracy, precision is also 100%, F1 score is also, so definitely we are getting 100% result here. And if you just see the last one, which was plotting the graph, so that graph is already here. I will just put it to your screen now. So if you just see, this graph is showing that the significant feature which is there, feature importance, the feature which is study hours, that is its importance is 60%, and the attendance is 40%. So 60% importance of the study hours, where a particular student will be how much a particular student has studied, and then the second one is the attendance. So the most significant one is the study hours, and the second one is the the attendance. So I hope this program, which is very simple, we have not added anything much into this. I would say nothing. Just we have just used a random forest classifier. Other aspects of this program, if you just see, if you just dissect it one by one and see these different steps. Step one, for example, this is mentioned here: importing libraries. Step two is creating data. So we have done it multiple times before, and then we are saying that training the model. All of this mode prediction, make predictions. So we are making predictions here, and then print the predictions which are there. And at the end, we are evaluating model on training data, and for the demo purpose, we are evaluating it, and then feature importance for that we are printing. Which feature is more important? So these separate components, if you just see, only one difference I can find, that we are using, instead of decision tree classifier, we have used here is the random forest. So random forest classifier, we are mentioning that estimators number of trees in this case should be 1, should be 10, sorry. And then that is the only difference that we are having. The rest, everything which is there, that has been previously done. So I don't think there should be any difficulty in understanding this. The basic concepts of this random forest have been given with the theory which was there. And then we have implemented one program which is showcasing the results. And in this case, I think the same example which we had done earlier with decision trees, if I'm not mistaken, it was giving result of 80%. Now this has enhanced to a huge extent when we are taking it with a random forest classifier. Stay tuned for this similar kind of videos for this particular series. In fact, especially we'll be going towards taking more advanced concepts, and in this category where we have reached now, random forests. And then after that, we'll be moving forward with some other important significant machine learning algorithm. So thank you so much once again for connecting, and do subscribe to the channel. And in fact, you will be getting intimation whenever a new video gets uploaded to this particular channel anywhere. So thank you so much once again for joining, and I wish that this will be beneficial to you, and you can provide your feedback, comments on the comment section. That will enable us to enhance for our future series, or future in fact topics that we are going to have in this very interesting series of machine learning. Thank you.